All right, we have another coding problem. We are given a sequence, we are given an array and we want to determine whether this array can be an arithmetic progression, meaning that you can rearrange the array in such a way that you get an arithmetic progression, meaning that the difference between any two consecutive elements is the same. So like, for example, one here, when you can form it 1, 3, 5, and then the common differences would be 2. Okay, so I guess the first thing to notice about this problem is that if you have an arithmetic sequence, if you have an arithmetic progression, then the elements need to be ordered in some way, either in increasing order or decreasing order. So like we see these orders here, 1, 3, 5 and 5, 3, 1, because basically for the common, whatever the common difference is, if that common difference between any two consecutive numbers, if the common difference is 0, then all numbers are the same. If the common difference is positive, then the numbers always increase by that amount. And if it's negative, then the numbers always decrease by that amount. And so the resulting sequences are ordered. Okay, so what we can do is we can just take this array and sort it. And then once it is sorted, we can just go through and check if the differences between any two pairs of entries are the same. Okay, so the first thing we need to do is we're going to sort it. Again, I am writing out my code by hand because I like to do that. So I'm going to start with array.sort. You could, if you wanted to, you could make you could make a separate array called sorted array, and then it would just be sorted. You could just apply the sorted function to array, and that would give you a separate array to work with. But we don't have any other use for the original array in this particular problem, and so we can just sort this array in place, and that's fine. Okay. So whatever this difference, so we want to see if the difference between any two elements is the same. So we can start by taking the difference between the first two elements. So this would be R1 minus R0, because if there is a common difference between any two pairs of elements, then it has to be equal to this one. Like any particular pair of indices, any particular pair of indices off by 1 will give you whatever common difference exists. So we can just choose the first one and start with that. And it's worth keeping in mind here. Okay, so you always want to be thinking, like, is this code going to explode? So is there anything that could go wrong here? And there is. This array, if this array doesn't have 2 entries in it, then this isn't going to work. But we look at the constraints, the length of the array is always at least 2. And so you're going to always have at least 2 entries. And so this line of code will always run. If we weren't given this guarantee, then you'd have to include some edge case, like if length of array is greater than or equal to 2, then do this whole thing. Otherwise, return true, because if it's, let's see here, in that case, I think you would assume, like, it would be vacuously true that a blank array or an array with 1 element is an arithmetic progression. Okay, but anyway, so this is if there is a common difference, it's this. So you could call this variable common difference if you want. I'm just going to call it difference. And then we're going to loop through And we want to loop through all the other pairs of indices. So here, the first thing we tested was index 1 minus index 0, or the value in index 1 minus the value in index 0. Next we would want to compare index 2 to index 1, then index 3 to index 2, and then keep going with that until you get to the end, which would be the final index in array minus that index minus 1. Okay, so where are we going to start here? We're going to start with 2 because we've already compared 1 and 0, and so the first thing we're going to want to check is 2 and 1, comparing the value in index 2 to the value in index 1. So we want to start with 2, and we want to go up to what is going to be the last thing. So so it's going to be something relative to the length of array. And we have to think, like, do we have any off by 1 errors here? So the index in the final entry of array is going to be equal to the length of array minus 1. Because that's how the length function works, because indices start at 0. So here in this range function, writing range from 2 to the length of array, this is going to include all integers up to, but not including the length of array. And that's exactly what we want, because the length of array is going to be the first positive integer that comes after the final index. Because the final index in array is length array minus 1, we want the final thing that we test to be length array minus 1. And so if we put length array here, then that ensures that we end at a length array minus 1, because this never gets to length array. You always stop right before it. Okay, so if it is true that this difference between the I and the I minus 1 entries is, if there's ever a time where this is not the same as difference, then we're going to return false. Because in order for this sequence to not be formable as an arithmetic progression, all you need is a particular pair to not be equal to the original difference. And so yeah, in this case, we will return false. If there's ever a time, or if there are ever any pairs of indices, if there's ever pairs of adjacent indices in array which yield a difference that is not equal to the difference that we started with at the beginning. Okay, but if we go through this entire loop and we never run into this condition and we never return false, then what that means is that we've checked every single pair of adjacent indices in array, and the corresponding values always form the same difference. And that's exactly what it means to be an arithmetic progression. And so if we exit this loop and haven't returned false, then we are in the midst of an arithmetic progression. And so then we return true. Okay, so there we go. And that should solve it. So let's try this out. We'll start by sorting the array. The difference is going to be the entry in 1 minus the entry in 0. And by the way, like this, the order here, whether you go increasing or decreasing, doesn't matter, because as you can see from this, you can generalize from this example that if you have them in increasing order and the difference is x, then if you put them in reverse order, then the difference will be negative x. And so And so if the elements in increasing order form, so the elements in increasing order form an arithmetic progression if and only if the elements in decreasing order also form, or if and only if the elements in decreasing order form an arithmetic progression. And likewise, if they don't form an arithmetic progression, it doesn't matter if they're increasing or decreasing by that same logic. I guess you could like write out a proof for that if you wanted, but it would be fairly straightforward. But yeah, so it doesn't matter whether we sort increasing or decreasing, so we'll just use the sort function and move on with our lives. Okay, so for I in range, and we're going to go from 2 to the length of array. Edge cases, it's worth thinking about what happens if this index 2 doesn't exist. Well, actually, let's write out the code first because it will help us answer this question. So as we loop through all the remaining pairs of adjacent indices, if we get a pair where the adjacent values have a difference which is different from the original difference, then we're going to return false. Otherwise, if we've managed to exit this loop without returning false, then the differences are all the same, and so we have an arithmetic progression, and so we return true. Returning to that question, what if there is no second index here? Then this is going, if the length of array is equal to 2, then this is going to be empty, and so this loop is not going to run at all, and so it's just going to skip down to return true, which is exactly what we want, because if there's only 2 elements, then it has to be an arithmetic progression. So yeah, we can submit this. And there we go, this code works. And so that is how you solve this exercise. I should write a book. People need to know about the can make arithmetic progression from sequence.